So chapter 27, 28, current, resistance, and DC circuits. So as it appears from the title, we're going to discuss currents, resistors, generators, receivers with DC currents. We're not going to talk about AC currents, only DC currents. So let's start. Nature of electric current. We all know what is an electric current. Initially, the electric current was defined as a flow of electric charge, no matter what is the sign of these electric charges. The flow of positive charge is also a current. The flow of a negative charge forms also a current. So the current comes from the notion of motion of electric charges. Okay, so it depends where these charges are moving. They may be moving in free space, they may be moving in conductors, in liquids. ممكن يكون في عندي motion of ions, not only electrons. Any charge in motion, it means we have a current. Okay, but in our practice, because we are talking about circuits, generators, DC generators, we are mainly interested in the current that we all know, which corresponds to the flow of electrons in a wire. So this is our current in our lesson and this lesson. So it will be easy to identify, and you all know this type of current. بكل الأحوال, as a summary, current comes from the flow of charges. These charges are either positive or negative. It doesn't matter. By convention, they have taken the positive, or the direction of the current is the same as that of positive charges, or opposite to the flow of negative charges. يعني إذا أنا عندي plus machine, so مثل البلس. إذا عندي so opposite to minus, يعني with plus. If there are plus and minus charges in motion at the same time, the current is with the positive charges. Always with positive charges, opposite to the flow of negative charges. This is by convention. This is taken the direction of current by convention. Why? Because as I have explained, we have two types of charges, and they had to choose how to choose a positive direction for the current. And it was taken with positive charges. So in our lecture, we won't talk about ions or the flow of electrons in wires, okay? In wires, which is our current in our case. Let's start with generators, okay? What is a generator? A generator is an electrical component whose job is to generate electric energy. It delivers electric energy. It gives us electric energy. This is a generator. It gives electric energy. How does it give electric energy? It depends. It may change chemical to electrical. It may change mechanical to electrical. يعني I'm doing some kind of motion, and from this motion, I'm creating electric energy. So this is a generator. هلا. In our case, these are DC generators. What is a DC generator? We all know that the DC generator, at certain circumstances, it gives a constant voltage. It gives a constant voltage for a certain current flowing through it or delivered by this generator. Usually, a generator has two characteristics. I'm talking about a DC generator. We are not responsible for AC generators. DC generator. First, it has two characteristics, which are the electromotive force and the internal resistance. What is the electromotive force? The electromotive force is usually a voltage, but we give it the symbol E. As it appears, it is a big E here. So this is the so this is from the old anyway. Someone has opened the microphone. Please, if you can close your microphone, please check your microphones. شباب صبايا, please check your microphones.
دكتور اسمها ديما.
ديما ديما can you hear us ديما فلت جوا okay so لا okay the generator has two characteristics which are E and R. E is called the electromotive force EMF electromotive force and R is the resistance. The resistance comes from the fabrication of the drive cell from its fabrication from كيف مصنعة. بكل الأحوال when we buy a DC generator for example a battery بيكون على الباتري مكتوب voltage for example 1.5 volt or 9 volt or 3 volt. This is the electromotive force. What is the electromotive force? By definition, it is the maximum voltage that can be delivered by the generator. But is it delivered all of it by the generator? The answer is no, if the generator is not ideal. يعني هو مكتوب عليه 1.5 but when it works because it will consume some of its energy and transform it to heat يعني راح يحمى شوي so it will not deliver E, it will deliver E minus IR. This small IR is consumed by the battery itself because it's going to heat. Okay, as if it contains a small resistor R. So instead of giving me E, which is the total electromotive force, it's a voltage E, it will give me E minus IR because some of the voltage will be consumed by the internal resistor of the dry cell. So I will repeat again. The two characteristics of the dry cell are E and R. E and R. E is the electromotive force. By definition, it is the maximum voltage that can be delivered by the dry cell. R is the internal resistance of the dry cell. It comes from the fabrication of the cell. Okay, so for sure R is small in comparison, or IR is very small in comparison with E, because the job of the generator is not to heat up, its job is to deliver voltage, but it will heat up anyway, even a little bit, but it will heat up. So يعني بلا ما تعطيني for example 1.5 volt, it will give me 1.4. So this difference هو IR. This is the job of the resistor or the loss due to the internal resistance. As you have seen from a generator, we have two poles, the positive pole and the negative pole. So we draw them similar to a capacitor, but the positive pole has a longer side than the negative pole. You all know this information. Okay, you all know كمان that the current flows from the negative pole to the positive pole of the generator, while the electrons move from the negative pole to the positive pole of the generator, while the current moves from the positive pole to so I make sure I'm saying it correctly. Okay, so
دكتور عم يروح صوت
صوتي عم يروح عندكم كلكم؟
Yes.
هلا
Yes.
Okay, so I will continue. I will... سامعيني هلا؟
ايه بس الجملة اللي قبل شوي قلتيها راحت كلها يعني بس طلع اخر.
Okay, so I will repeat again. I was talking. You all know this information. I was talking about the current. The current flows from plus to minus of a generator, and electrons flow opposite to current. Or who بالحقيقة current flows opposite to negative charges because here we have flow of electrons usually in wires. So electrons flow from minus to plus, and current moves from plus to minus. So you all know this information. So we have to know that for a generator, the voltage VPN is equal to E minus IR. E minus IR. So E هي maximum voltage وال IR it's the voltage due to the internal resistance. هلا if R small r is equal to 0, we call our generator an ideal generator. It's called an ideal generator. So as you can see, it's called an ideal generator. And in this case, VPN it's equal simply to E. There is no R. So بنرجع نحن نقول إنه ال VPN هي بس E. إذا اعتبرنا resistance كتير صغيرة. So in this way we can consider that the generator is delivering the maximum voltage E and it's not consuming any part of this voltage for itself. Okay, so this is for a generator. I want just
دكتور عندي question بس بهيدا البوينت.
Yes, ask.
دكتور يعني نحن in general كل الباتريز حيكون عندهم هيدي الانترنال ريزيستنس.
Yes, they will have this.
اوكي إلا إذا كانت
they don't contain. So
كتير قريبة من الزيرو بتكون الباتري plays the role as the generator.
Let me take a look on exercise. مثلا هون in this one doesn't have an internal resistance. Neither this one has an internal resistance. So they don't have an internal resistance. Here, this one has no internal resistance, only E. Okay? So where كمان مثلا هون كمان ما عندي internal resistance in the question. كمان هون ما في internal resistance. هون بس في هون هذا receiver بعد ما حكيت عنه. So this is a receiver. So وين بعد في? So this one has an internal resistance.
اوكي دكتور بتكون ساعتها.
But usually without resistance it is easier. Okay?
Okay.
What was your question بالنسبة لل E وال R?
دكتور سمعتنا؟
سمعتك. What was your question for E and R?
عم بقول لك إنه هن بالعادة يعني in general بس بدهم يحطوا الكاركترستكس لهيدا الجنريتور بيكون عنده internal resistance إلا إذا كانت كتير قريبة من الزيرو بتكون ساعتها ideal هيدا الجنريتور.
صح. It is not given in this case. Only E is given.
اوكي نحن اذا عملنا كالكوليشن بتكوني انت لانك اوريدي حطيت لنا على الاي في حد هيدي السمول ار يعني هي it exists الانترنال ريزيستنس.
Yes. If it's written it exists. If it's not written it does not exist. It means this is an ideal generator. So instead of writing VPN equals E minus I, I would just write VPN equals E. Simply. Okay.
لحظة.
I have to add something. And sometimes in some circuits we have more than one generator. So what happens if we have more than one generator? I will give you two simple examples. Let me take this generator and a second generator beside my first generator. So here's a plus, this is minus, this is plus, this is minus, and this is it has E1 R1 and this one has E2 R2. So in this case, let me say E1 or the first dry cell and second dry cell, they are connected in series. If they are connected in series, so the current will flow in my case also the first dry cell will give a current to the left and the right dry cell will also give a current to the left, so there's no problem, both of them will give current in the same direction. And we may say that in this case, sorry for that, and we may say what's happening. Okay, so we may say that the current flows in its direction and both the dry cells are acting as generators. So when both dry cells are connected بشكل إنه الماينس على البلس يعني بيعطوا current بنفس الاتجاه, so we may say that both of them are acting as generators. But the problem lies if, for example, we have connected two generators not and same as the previous way. These are called connection in opposition. What do we mean by connecting them in opposition? It means البلس حد البلس أو الماينس حد الماينس. So if they want to give currents, so we can see clearly that the first one will give a current opposite to the second one. So what will happen to the current? No, أكيد مش اثنين currents رح يمشوا بالcircuit. Only one current moves in the circuit. What happens in this case? In this case, we check the EMF, يعني EMF of both dry cells. The one that has larger E, يعني اللي عندها electromotive force أعلى. So اللي عندها مثلا, for example, if E1 is greater than E2, so in this case, the first one, أو خلينا نسميها هيدي 1, هيدي 2. So 1 will act as a generator because its voltage is larger than E2, and 2 will act as a receiver. So in this case, what will happen? What will happen is that the current will move based on 1 and not based on 2. So if you take a look, the current is leaving from the positive pole or the positive pole of dry cell 1, while the current is entering through the positive pole of 2. So in this case, 1 is called a generator and 2 is called a receiver. Okay, but in comparison with the first case, no, in the first case, 1 and 2 were both of them acting as generators. How do we configure if it's acting as a generator? If it's giving current from its positive pole, then it's a generator. If the current is arriving to its positive pole, then it's a receiver. It's receiving energy, electric energy. So in the second case, where they are connected in opposition, بتشوفوا إنه the current leaves from 1, but it arrives to 2. So 1 is acting as a generator and 2 is acting as a receiver. Why does this happen? Because the current must move based on 1 or 2. It can't move based on both of them. وعندي أنا E1 greater than E2, for example. So 1 will be the generator, the one who leads the circuit, and 2 simply will be a receiver. Receiver, what is a receiver? I will explain a receiver. Receiver is an electrical component that consumes energy. It does not deliver energy, it consumes energy. Okay, so this is just a note for you. When we solve, I will explain it again. Okay, so this is for generators. Now let's talk about receivers. نعم. Yes.
لما بيكونوا اثنيناتهم generators الفولتج بالسيركت كلها قد ايه بيكون او مجموعهم؟
Yes, it's the sum of them, but it depends كمان if they are connected on the same wire, if they are connected on different wires. So it depends on the circuit. So let's take a look on the exercises we have. So here, for example, look at this exercise. Application 1. We have these two. So if we take a look on this exercise, هون عندي this is dry cell 1 and this is dry cell 2. You can see clearly that they are connected in series while in opposition. Anyone can answer?
Series.
In series because plus and minus simply. So both of them in my case will act as generators. So حتى when we solve لحالهم رح يطلعوا they will add up. بس نحل بصير تلاحظوا رح يطلع معي E1 زائد E2. So it depends on the question. So these are normal questions. But home, for example, in my case, here is a case. E1, E2, and E3, our 3 dry cells, they are on different branches. في عندي هون 3 currents. Okay, so which one is a generator, which one is a receiver, which one يعني يمكن يكون 2 generators واحد receiver. ممكن واحد generator و 2 receivers. We don't know. Okay, ممكن 3 generators. Okay, it depends. بس لازم يكون بعد في branch يكون الجنريتور. يعني إلا ما واحد يكون عم يستقبل. Depends. يمكن يكون 3 generators حسب البولاريتيز تاعولن. How do we know if they are generators or receivers? Okay, we check the current. We calculate the current. And after calculating the current, we check if the current is leaving from the positive pole of my dry cell, say it's a generator. If the current in the branch is arriving to my dry cell, it's a receiver. That's it. That's how we know if it's a generator or receiver. This is the whole idea. Did you get the idea?
Yes.
So that's it. It's very easy. Now let's talk about a receiver. What is a receiver? A receiver is any electrical component that takes electric energy and transforms it to any other form of energy other than heat. So it's not a resistor. Resistor is different from a receiver. Receiver, it does a job with the electric energy. It may be mechanical, it may be chemical, I don't know, some job, okay, but not heat. But due to its fabrication, it has an internal resistance R. So if you can see from the characteristics of a receiver, it has back electromotive force E and internal resistance R. So we will get the voltage of a receiver E plus IR. So رح أرجع أعرف what is back electromotive force. Back electromotive force, it is the minimum voltage needed by the receiver in order to function. هلا في الفرق ليه هون E minus IR plus IR and up the formula was E minus IR. Simply because the function is different. I will explain why. In the generator, it has a voltage E. It tries to deliver this voltage to the circuit. هو بيحمى. So instead of delivering E, it will consume part of the voltage and it will deliver E minus IR. This is for the dry cell. Now for the receiver. The receiver needs to function E, which is called the back EMF. كمان رح يحمى. So رح يصرف E وكمان رح يصرف IR. So it will use a voltage E plus IR. Did you get the idea why the upper formula is E minus IR and this formula is E plus IR?
دكتور بس please can you repeat آخر واحدة about the receivers?
Okay, so the receiver it does a certain functioning. It depends on its characteristics. But anyway, it's consuming electric to change it to something else. So it needs a certain voltage to do this work. Okay, بدها voltage E. وكمان هي راح تحمى. So it will consume E to do its work, plus it will consume IR in order to transform some of the internal resistance to heat, or due to the internal resistance to heat. Okay, so this is for generator. So don't worry, solving them is very easy. This is the most amazing lesson in this chapter. So it's very, يعني حله كتير حلو. Okay, so just you know some tricks and it's okay, you can solve it. يعني مهم generators everything كل شيء بيعطيني كهرباء E minus IR everything consuming E plus IR. أكيد الريزستور بتعرفوا IR. I will explain it down كمان. Let's talk about the electric current. I will explain them rapidly, so we're not asking about these two slides anymore. So I will explain about them in a fast way. So you know what is an electric current? We have said that electric current is related to flow of charges. So what is by definition the current? The current هو charge, it's defined as the rate of flow of charge or flow of charge per unit time. يعني if I have a wire, how much it charges, how many coulombs are crossing my area in 1 second. هذا تعريف الكرنت. يعني if I have a current 1 ampere, that means 1 coulomb is crossing my wire in 1 second. الكولومب يتشارج عم تقطع بالواير خلال الثانية الواحدة. This is the definition of current. Okay, this is the definition of current. So if I want to define current in a different way, so let's just talk about, suppose that the current consists of n charge carriers per unit volume of drift speed V. So assume we have here electrons or carriers of charge, anything that's carrying my charge. And these carriers of charge, each of them has a speed V. N, it is the density per unit volume للكاريرز اللي حاملين التشارج وماشيين. شو يعني density per unit volume؟ كلكم تعرفوا يعني number of charges بالunit volume per meter cube. Number of charges in 1 meter cube. So this is the density per unit volume. So this is the N. So إذا أنا بدي أحسب الدي كيو يعني أنا when during small motion of my carriers or my charges, you can see that my charges will move a distance dx. This dx is equal to v dt, where v is the speed and dt is the time. So هاي dx. So الكاريرز رح يمشوا هالمسافة بقلب الواير. So dq, how much energy or how much charges have moved in my wire in this small volume اللي هو dv بالنسبة لي أنا. So simply dq it's equal to rho times dv. It's rho times dv. What is rho times dv? rho هيدي هي الفوليوم density of charge أو charge volume density اللي نحن كنا بنعرفها من قبل. يعني قد ايه في عندي كولومب بالمتر كيوب الواحد اللي هي عندها كولومب per meter cube. This is coulomb per meter cube. The rho that we all know, the rho اللي هي coulomb per meter cube اللي هي volume charge density explained earlier times dv. هلا بالنسبة للرو, what is the relation between rho and n? الان هي number per unit volume بينما الرو هي charge per unit volume. أنا بعرف إنه كلهم عندهم نفس charge هي Q. Okay, so simply rho it's equal to n times Q or Q times n. راح ارجع اعيد. الكيو هي charge او charge volume density او volume charge density. هيدي الرو يعني كم كولومب عندي بالمتر المكعب الواحد. الكيو التشارج للواحد. الان number of carriers in 1 meter cube. So if I multiply them, I will get 2. Okay, this is for rho. Now, the volume dV, as you can see from my portion that I have taken, so dV is equal simply to A times dx. This is dx, where dx is V dt. So A is the area of the wire. So if I arrange everything, I will get I equals dq by dt. So arrange, I will get nqva. So what are these elements? I will repeat again. N هي density per unit volume. يعني كم كارير عندي بالمتر المربع الواحد، متر المكعب الواحد، meter cube. So number of carriers in 1 meter cube. The Q, charge of one carrier. The V, the speed of carriers. The A, the area of my wire. So these are the 4 parameters or the 4 letters. So you can see that the current I depends on the speed of the carriers, the density of the carriers, and the area of the wire. Sometimes we define something different. So current density, what is current density? يعني we have seen that I, the current, depends on the area. When the area increases, the current increases. So we define something called the current density, which is given the notation J. J is equal to I over A. Simply we divide I, which is equal to NQVA, divide it by A, we will get NVQ. So J فعليا عندها unit هي ampere per meter square. And how many amperes do we have in 1 meter square? So as if it is some sort of density. Okay, so instead of giving me the current, you can give me the density. I multiply by the area and I get my current. So this is the relation between the current and the current density. So the current density can be written as rho V. So later on, if you encounter some, if you are chemists and not biologists, you will see this formula, J vector equals rho V, because NQ, it's simply rho, it's equal simply to N times Q. Okay, remember, rho هي الفوليوم charge density بينما الN هي number charge density. So simply number charge density هي multiply by Q, you will get rho. That's it. Okay, so this is for current density. In the last few years, we did not ask about the current density. Okay, we used to ask about it, we used to use it, but كمان we never asked about it, and I think this year we won't ask about it, because I'm just explaining them for you. So now let's talk about resistors. Resistors are very easy. The job of the resistor is to change electrical energy to heat. It's not a receiver, it's different from a receiver. It has no EMF, ما عنده back EMF, ما عنده. Okay, عنده بس resistance. So you have seen that generator has 2 characteristics, a receiver 2 characteristics, a resistor has only 1 characteristic, which is R. Usually a resistor is used in a circuit in order to control the current. We control the current using a resistor. How? Each time we increase the resistance, we lower the current. Each time we decrease the resistance, we increase the current. So we can use resistors as a method to control currents in a circuit. So this is the using of resistors in electronic circuits, but its job is to dissipate energy in the form of heat. You all know that according to Ohm's law, VAB equals RI. Resistance has a unit of ohm. Resistance is constant, by the way, it's a characteristic. What do we mean by a characteristic? على فكرة ال E والR للgenerator, ال E والR للreceiver, والR للresistor are all characteristics. Characteristics, it means that even if we change the circuit, if I change the connections, if I add another element to the circuit, they do not change. What does change is the voltage and the current. الR والE والR الصغيرة ما بيتغير، هو بس ما بصير له شيء. They always remain constant. What it changes
مثل
is R and V. صح، مثل الكاباسيتنس ما بيتغيروا هون، يعني اذا انا مثلا سكرت سويتش فتحت السويتش كذا الار بتبقى ار ما بتتغير، بس الفي جديد بصير واي جديد وحسب. it depends on the case that I'm dealing with. okay هلا if we have a cylindrical wire sometimes هلا كمان we used to ask about this but we no more ask about it. I will just explain it rapidly. For a cylindrical wire the resistance R it's equal to rho L over A. So if I have a cylindrical, I will talk about each element alone. A cylindrical wire, you know all wires made of metals they have certain resistance. وكل ما كان الواير أكبر كل ما resistance بتكون أكبر. So they have found that the resistance of a wire, of a cylindrical wire, is equal to rho L over A. What is rho? Rho هيدي اسمها resistivity. Resistivity. What is resistivity? Each material has its own resistivity. It's a constant. So copper has resistivity, aluminium has, iron has resistivity. This is a constant for each material. قد هي عندها resistance هالماتيريال. So rho is a constant for each material. L, length of the wire, and A is the cross-sectional area of the wire. So you can see that if the length is, يعني if my wire is long عنده L كبيرة, the resistance will be large. If the area is large, I will get small resistance. وهذا الشيء منطقي لأنه أنا بصير عنده الإلكترونز بيتحركوا بحرية بيتحركوا بسهولة. بينما if A is small يعني الاريا صغيرة بصير ضيق الواير الريزيستنس بتصير عالية. لأنه الريزيستنس هي نتيجة the flow of charges inside the wire or a resistor. So if they can flow freely or easily, so the resistance is small. If it's hard for them to flow, then it means that the resistance is high. Okay, so this is the resistance for a wire. Now let's move. I'm moving fast because they are all old information. Nothing is new. So grouping of resistors. I've explained already grouping of capacitors. Here, grouping of resistors is opposite to grouping of capacitors. Okay, so let's start with resistors in series. Before grouping them, remember كمان again that if they are in series, here they have the same I. Okay, if they are in parallel, they have the same V. When we dealt with capacitors, we said they are connected in series, they have the same Q. If they are connected in parallel, they have the same V. Why do we keep this in our mind? Because we sometimes use them when we solve, okay? If we have some information about one resistor and we want to find an information about the second resistor, which is a neighbor of the first. So here you can see that my three resistors are connected in series. I have R1, R2, and R3. From law of addition of voltages, VAB equals VAC plus VCD plus VDB. So it's clear that, okay, so this is my law of addition of voltages. And I will replace each one by its value. So VAB, it's simply V equivalent times I main. You can see it's I main. VAC, it's R1I. VCD, it's R2I. VDB, it's R3I. So get rid of I or divide by I the whole line. We will get R equivalent equal. So R equivalent equals R1 plus R2 plus R3. So in series we add resistances. That's it. In series we add the resistances. So كيف بنعمل equivalent same as the capacitor. How to remove the capacitor, to remove the resistor, add the equivalent resistor, same as we have done for a capacitor, same way. Okay, but the equivalent here, the formula of the equivalent is different. Let's talk now about grouping of resistors in parallel. We have three resistors as you have seen in parallel. From law of addition of currents, you all know that I is equal to I1 plus I2 plus I3. Okay, so in this case, we can say that I is equal to VAB over R equivalent. I1 is equal to V1 over R1. I2 is equal to V2 over R2. And I3 is equal to V3 over R3. Okay, so using law of uniqueness of voltage, يعني VAB it's equal to V1 equal V2 equal V3. So I can get rid of these. I will get 1 over R equivalent equal 1 over R1 plus 1 over R2 plus 1 over R3. So this is for grouping of resistors in parallel. I won't take too much time to talk about that. You already know that since school. يعني. Okay.
دكتور يعني حتى بالبارallel عنا بيكون same voltage.
ايه اكيد I can use the same techniques as يعني هون شو بنقول اذا انا كنت عم حل parallel same voltage الكارنتس مجموعين هون فوق الكارنتس same الفولتجز مجموعين okay but I prefer usually to use الهنت انه مثلا ال eyes are the same so اذا انت تعرف ال eye okay
دكتور
Let's
راح
talk-
صوتك.
دكتور راح صوتك.
راح صوتي Let's talk about energy in electric circuits. Usually, it depends on the electrical component that we are studying. If we are studying a generator, so we are interested in the power delivered by the generator. If we are talking about a receiver or a resistor, we are mainly thinking about the energy dissipated by this resistor or this receiver. نعرف الجنريتور بيعطينا الريسيفر بياخد والريزستور كمان بياخد. So الباور the formula of the power شو ما كان الانسترومنت هي وحدة V times I ما بتتغير إن كان ريزستور ولا ريسيفر ولا جنريتور. It's simply voltage times current. It doesn't change. Okay, so by definition P power equals energy over time. This is energy. Okay, so energy over time, it's voltage times current. If I'm talking about the power of the generator, it's the voltage of the generator times the current passing through it. If I'm talking about a receiver, voltage of a receiver times current passing through it. If I'm talking about a resistor, then the voltage of a resistor and the current passing through the resistor. Okay, for a resistor, we have a more beautiful formula. We can replace V by IR or RI. Okay, so if we replace V, so if we have P equals VI, if we replace V by RI for a resistor, we will get RI squared like this. Or we can replace I by V over R. So V over R, بيطلع مع الفورمولا V square على R. So this formula down is only for resistor. The one that is up is for all electrical components. It's V times I. It's always true. Okay, so this is the energy. Now done for energy. Now let's talk about Kereswarf's rules. So this may seem new, but in reality it's not. It's the same as the methods that you already used, but they are just formulated in a different way. So usually when we are going to solve, sometimes we can't just make our circuit simple. يعني we can't just make R equivalent or C equivalent and then solve. Sometimes the circuit is more just complex than that. Similar to the circuit that I have shown you, in which we have a dry cell in each branch. So I can't do R equivalent or C equivalent. I can't because there are batteries everywhere. So I can't get rid of them. What happens in this case? It's very easy to use Kirchhoff's rules. So if I have a complex circuit, I use Kirchhoff's rules. What do Kirchhoff's rules help me to? They help me to find the current in each branch of my circuit. Okay? So instead of using all Ohm's law or simple Ohm's law to find the current in my circuit, I will use now Kirchhoff's rules. Kirchhoff's rules are already known for you, but you know them in a slightly different way. We will introduce them here in the method of Kirchhoff. Okay, so let's see first rule. What does Kirchhoff's first rule say? It's the junction rule, or first Kirchhoff's rule. You all know it as law of addition of currents. You know it as this form. But according to Kirchhoff, it says that if we have multiple currents at a node, okay, or at a junction, then the currents arriving, the sum of the currents arriving to the junction is equal to the sum of currents leaving the junction. So here in my case, take a look. I have I1 arriving at junction. هيدي هي junction, okay? This is my junction. I have I2 leaving, I3 leaving, I4 arriving, and I5 leaving. So I have I1 plus I4. I1 plus I4 are arriving, and who's leaving? I2 plus I3 plus I5. So this is Kirchhoff's rule. It's very easy. This is one of the equations that I can use. We know in each circuit we have unknowns. For example, we have three currents unknowns, I1, I2, and I3. So we need the three equations to solve the three unknowns. This is one of the equations that I can use to solve my equations. Okay, so Kirchhoff's rule gives me one equation to be solved. I have to arrange equations depending on the number of currents that I need to find. And if I have three unknowns, I need three equations. If I have two unknowns, I need two equations. If I have one unknown, I only need one equation. So I just use the equation. This is one of the equations that we use in order to solve the unknowns. What are the unknowns? The currents. We are searching for the currents using Kirchhoff's rules. Okay, so what is a junction again? Yes.
دكتور الجنكشن لازم تكون more than 3 wires ولا إذا كان عندنا 2 wires
الجنكشن يعني أنا بمعنى
junction؟
آخر I will just explain. أنا كتبتها هيك كهند. مثلا let me take a look. هون هذه النقطة اللي in blue. This is a junction. How many wires do you see? 1, 2, 3, 4. تمام? Let me take another point. For example, this red point or orange point. Is this a junction?
No, لأنه عندنا بس 2 wires.
It's not a junction. Simply, when the current arrives, it won't decompose to two parts. It will remain one current flowing. Junction هو محل ما في احتمال ينفصل الكرنت. It will divide.
اوكي يعني فيني اقول انه هي بس لما يكون عندي 3 wires واكثر.
صح. يعني where do we have a junction? I will color them with blue. So here this is a junction. Here this is a junction here. هون مش junction. Where do we have? Okay, these are بعد في junctions? No. The others are not junctions. هون هيدي مانا junction in orange. This is not a junction and this is not a junction. This is not a junction and this is also not a junction. هيدا simply أنا رسمة سيركت مربع بس هي إنه it's not a junction.
Okay, doctor.
Okay. Okay. So the ones that are colored in yellow or orange, they are not junctions. The ones that are colored in blue are junctions. So we have 3 wires and up. Simply a junction is a place where the current will divide or meet another current, will group up with another current. يعني not only one current will just be moving in its way. It will either divide or group with other currents. Okay. Kirchhoff's second rule. Kirchhoff's second rule, it is simply called the loop theorem. And what does it say? It says that if you add the potential differences along a closed circuit, you will get a voltage zero. You will get a voltage zero. What does this mean? Okay, so like what does it mean? Let me take a look on. Okay, so if I take, you all know the potential difference. بس إذا أنا بتحسب UAB أو VAB. نحن بنبلش من ال A وبنرجع بنوصل لعند ال B, and this is how we calculate the potential difference. I will teach you how to solve when we solve the problems anyway. So start from A and just finish to B. How to move from A to B? You can move any way you like. على فكرة when you calculate the voltage فيكم تمشوا مثل ما بتحبوا. يعني فيكم تمشوا إذا أنا عندي هاي ال A هون وهي ال B هون. I'm writing in let me write in red. Okay. So أنا فيني أمشي من ال A لعند B. أنا مشيت حسبت ال E1 وحسبت ال E2 والريزستور 3 أوم والريسيفر وال5 أوم وصلت لعند ال B. Okay, it's true. إذا حدا قال لي أنا ما حابب أحسب هيك، أنا حابب أحسب هيك، إجي من هون هيك هيك، بيمشي الحال؟ كمان صح. So calculating the voltage does not depend on the path how you are calculating the voltage. It always will give you the same answer. انا عم بحسب VAB، ببلش بالA بخلص بالB. This is how to calculate the voltage. اوكي، فيني امشي مباشر direct، يعني احسب انا بدي احسب VAB. If I want to calculate VAB, I can calculate VAB using the blue line. I1 times 4 ohm, the voltage of the resistor, which is 4 ohm. I can do that. All of them will give the same answer. ما دام أنا عم بلش أحسب من ال A وأخلص حسبان بال B. Did you get the idea?
Yes.
Okay. So what does Kereswarf say? Kereswarf say إن إذا أنت بتعمل برمة على لوب كاملة, the sum will be equal to 0. So assume مثلا I'm taking a point here. I'm taking a point here called C. Or let me take it called C. Okay. So إذا أنا بدي أحسب V, بلش من عند C وأبرم على السيركت على الوايرز وأرجع لعند C. وأنا عملت VCC اللي هي البوتنشال difference ما بين C و C اللي هي فعليا VC minus VC which is equal to 0. يعني أنا عم أجمع كل الفولتجز، بلشت من السي وخلصت من السي، يعني أنا جمعت كل الفولتجز من السي لعند السي. So I'm calculating the potential difference VC minus VC اللي هو 0. So if I add all of them along، يعني بلش أنا بالنقطة وببرم على الوايرز وبرجع على نفس النقطة اللي بلشت فيها، لازم الفولتج مجموع الفولتجز يكون صفر. Simply لأنه البوتنشال difference على نفس النقطة هو صفر. Did you get the idea؟
يعني مهم بلش من نفس النقطة وارجع على نفس النقطة.
هلا when we solve I will teach you how. You can choose any point. مهم تبرموا، فيكم تبرموا يمين، فيكم تبرموا شمال، فيكم تبرموا كيف ما بتحبوا. مهم على الوايرز انتم ماشيين وتحسبوا كل شيء موجود. يعني بنحسب نحن انا كيف ماشي، في عندي الجنريتور، بيجي عندي ريزيستور، بيجي عندي ريزيستور الثاني، بيجي عندي ريسيفر، بيجي عندي ريزيستور، عندي الجنريتور، بنحسبهم كلهم مجموعهم بيطلع صفر. They are very easy to solve. Once I solve one example they will be يعني دغري واضحين. So don't worry. Okay, so this is the second law of Kereswarf. But I will teach you things that are important.
ممكن ترجع شوي على الاكسرسايز على هيدا السيركت.
Yes.
دكتور الفي للاي بي كمان فيني اجيبها من هيدا اللاين اللي عامل مثل اكس بالسيركت الصغيره، يعني من ال 4 اوم على 2 اوم بوصل لعند البي.
صح. Yes, يعني we can. كلهم صح. كلهم صح. All of them are true. يعني إذا أنا معي الكرنت والله أنا فيني أمشي هيك وبيرجع هيك. Yes, I can do that. هيك قصدك؟
ايه هيك قصدي.
اوكي، لكن باخذ الكرنت اللي ماشي بالأربعة اوم ومع الاثنين والكرنت ماشي بالثاني. ايه صح. But I have to يعني لازم يكون معي currents. So how to solve depending on the given. يعني أنا بمشي من محل ما في given، ما بستفيد من محل ما في given. We make benefit of the given of the exercise. But anyway, it depends on the things that we are solving. So don't worry. Once I solve only one example, they will be very very easy. طيب بس عم كل التريكس اللي أنا بحتاجها أنا وعم أشتغل. Okay, so you will see we will count the voltages on the circuit. We will add them together to give me zero voltage. بكل الأحوال, so I will encounter three types of electrical components: generators, receivers, أو resistors. So I have to make sure كيف أنا ماشي بالgenerator. هلا أنا لك كيف أنا بعمل a certain method. You may use the same method that I use, okay, or you can use your own method. أكيد إذا أنتم كيف تفهموها هيدا الشيء بيرجع لكم. أنا إذا عندي جنريتور، إذا أنا عم أحسب وطلع معي الجنريتور. This is okay. If I'm moving along the wires من البلس لعند الماينس للبول of the generator, I place the formula E minus IR. إذا أنا عم أحسب من الماينس للبلس، يعني if I'm circulating this way, let me go back to my example. يعني assume أنا عم أبرم على السيركت. Let me erase this. اوكي، سو اسيوم انه انا عم ابرم هيك. انا بلشت من هون بدي ابرم هيك. اول شيء لقيت الجنريتور. سو انا عم اجي من البلس لعند الجنريتور لعند الماينس للجنريتور. سو هيدا بحط الفولتج تاعوله E minus IR. بس هون الار ما في، يعني بلس E only. سو بس فوت بالبلس بحط بلس E. تمام؟ هي القاعده. بس اجي من جهه البلس بحط E minus IR. اوكي؟ الاي ار ما في هون بحالتي، بحط بس E. يس؟
فيكي بس ترجعي تعيدي لأنه قطش.
Okay, I will repeat. The first formula. You are moving on your wires in order to add all the voltages to put them up, to sum them up to 0. You look what is inside the wires or on the wires. If you encounter a generator, okay? So in this case, if you are moving from the positive terminal to the negative terminal, or you are moving from the positive pole of the generator to the negative pole of the generator, you place the formula E minus IR. If you are moving from the negative terminal to the positive terminal, بالعكس, you put a minus in front of it. It's simply minus E minus IR. لأن بتعرفوا كلكم VAB equals minus VBA. So VAB equals minus VBA. This is the first one. If you are calculating the voltage of a resistor and you are counting the voltage مع اتجاه الكرنت for a resistor, then it's RI. Opposite to the flow of current, it's minus RI. Okay? هلا الريسيفر نفس مثل الريزستور. So receiver is أنا مع الكرنت هي E plus RI. Opposite to the flow of the current هي simply E minus but minus E minus RI. I will allow you to see it using this figure اللي أنا عم بشتغل عليها هون تحت. Okay, so I will help you just see it. أنا كيف راح أمشي؟ هو قال لي Kereswarf. It's very easy, so don't worry. Just once I solve one example, it will be easy. So نحن قال لي فيك تمشي محل ما بدك. أنا راح أمشي هيك بهذا السؤال. هيك 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 هيك. Okay, so I will start from C. I will start this way. You can move clockwise, counterclockwise. All of them are true. So let's see how does using the second Kereswarf's rule applies. أول شيء, what do we see? We see a generator. شايفين generator? This is generator. This exercise is not about this method, but anyway, I have to use it. أول شيء شايفين generator نحن. The generator كيف جايين؟ جايين من البلس على الماينس generator. So we simply write E2 minus IR. والI هي الI main لأنه هي الI اللي مرقة فيه. هلا أنا مساقبي هون ما في R, so this term is 0. هيدي أول شيء لأول generator. خلصت منه. هلا شو في عندي ورا؟ في عندي ريزستور اللي هو 3 اوم ريزستور. الكرنت كيف بهذا البرانش؟ الكرنت هو هيك. هيدا الكرنت. اوكي؟ So as you can see أنا لما عم أحسب الريزستور جاي بعكس الكرنت, so we simply write minus 3i. So for a resistor إذا أنا بعكس الكرنت we write minus. إذا نحن جايين مع الكرنت we write plus. من بعد الريزستور في عندي ريسيفر. كمان أنا جاي بعكس الكرنت للريسيفر. So we simply add minus. The formula of the receiver is E. هي بسميها هو E prime. E prime plus RI. كمان هون ما عنده هو R. So simply this is 0. بعدين ال5 أوم شو في عندي؟ كمان بعكس الكرنت. So minus 5I. كمان minus 5I. لأن هو resistor RI بعكس الكرنت minus RI. بنجي عند هلا خلصنا من هون بنجي عند ال4 اوم اللي هو فوق هيدا ال4 اوم. هيدا مش مرق بقلبه اي مين، هيدا مرق بقلبه اي 1. اوكي؟ سو كمان انا بعكس الكرنت اللي هو اي 1 بحط ماينس 4 اي 1. الريزيستنس تايمز الكرنت. الفولتج اوف ا ريزيستور هي ريزيستنس تايمز الكرنت. خلصنا وصلنا عند الريزيستور. شو؟
سوري، كيف عم تعرفيها بالعكس؟
انت كيف لايكي كيف راح فرجيك عليهم كيف للاتجاهات. طلع انا ماشي هيك بيرجع هيك بيرجع هيدي بيرجع هيدي بيرجع هيدي بيرجع هيدي. خلصت ما عادش فيهم. شفتي كيف عم بيجي بعكس عم بحسبهم انا؟
يا دكتور لانه القلم كان عم يطول عندي ليبين.
اوكي مش الحال.
مش الحال. ثانك يو.
اوكي سو وصلنا لعند الفور اوم اللي هي فوق. اوكي كمان نحن بعكس الكرنت سو ماينس 4 اي. بنجي عند الاي 1. الاي 1 جنريتور انا عم بيجي من جهه البلس للجنريتور. شو بحط؟ بلس اي 1. هلا هون ما في ار اي سو هيدي راح تطير. كلها هيدي ايكوال 0. هيدي كيرشوف. فيك تمشي على البيج لوب، فيك تمشي على السمول لوب، فيك تمشي على التريانجل. مهم ترجع محل ما تبلش ترجع كيف ما بدك تبرم ابرم. usually we choose the easiest one. اوكي فيكم تبرموا على هيدي هيك فيكم تبرموا، بس حدا حاب يبرم كيف بدي أبرم لكم؟ كلهم صح، كلهم صح، أنا حاب حدا يبرم هيك. تمام
بس
صح.
كيف خلاص آخر وحدة؟
اخر وحده بالبطاريه او بالجنريتور ما بنطلع بالكرنت. انا ما بطلع هلا فينا نطلع بالكرنت، بس انا الطريقه اللي بعتمدها انه ما بطلع بالكرنت، بطلع بالبوزيتيف بول. بس تكون انا جاي من جهه البوزيتيف بول بحط بلس. جريت.
بس خليني عليها من وين جاي؟
هيا انا رسميتها فوق مرسوم بالاورنج. نحن جايين عن الاي 1 عم تحكي، ما هيك؟ نحن جايين من هون لهون، نحن جايين من جهه البلس لعند جهه الماينس، يعني نحن جايين من البلس فبنحط بلس. اوكي
اوكي.
اوكي. مثل الاي 2 نفس الشيء، الاي 2 كمان كنا جايين من البلس حطينا بلس، جايين من البلس.
دكتور أريدان.
ايه خلصنا نحن بالنسبه لليوم، ما عاد في
دكتور بس لحظة شوي.
بعد في هدول الريماركس. اوكي so I'll just read the remarks. هلا برجع بتساليني. اوكي so let me just read the remarks to finish the lesson، وبرجع اللي عنده اسئله بيسالني اكيد. So we may encounter in our exercises ammeter, voltmeter, ohmmeter. You all know this information. Ammeter used to measure the current, voltmeter used to measure the voltage, and an ohmmeter is used to measure the resistance. You know that the ammeter is connected in series, voltmeter is connected in parallel. So this is just general information. You all know this information. So I will stop just recording. So stop.